Hi, I'm Jacob Stone. I'm working with Patrick Kineski and Aaron Warren, and we're going to demonstrate today our environmental management system. The basic communication scheme is that we have a Raspberry Pi right here is connected to the internet. He's going to pull in all the information from the web server over here. This is what we call our repeater module. It's going to repeat all the information it hears from the base module and send it over to the node devices, which are shown up here. And then the nodes actually have the sensors and the outputs connected. So I'm going to flip the switch right here. In a couple seconds here, you should see everything power on. I got the flashlight here, so you can see the light turn on and off based off of the sensor. It'll come back on. I don't know if you can see it. There's also another relay right here that depends on the same condition. So right now you could have two lights if you wanted it. Just the relay isn't actually connected. And then I'll get my pipe here, put it up close to the humidity sensor here and blow on it. That'll just make sure that the temperature comes up and the humidity also comes up. So what'll happen is the fan is going to turn off and also the humidifier should turn off, because most of them depend on that. So here goes nothing. So basically the DHT11 that we're using takes a couple seconds to work, as you can see. So we have it on a 3-second delay. So what you'll probably see is the fan's going to come back up, since the temperature takes less time to actually calibrate the sensor back to a normal condition. But then again, it might take up to 20 seconds or something before it actually works. So as you can see, all the inputs actually do work, and everything's changing based off of the conditions that we provide. Okay, so we're here at the website, and I'm just going to log in. So it's pretty easy to use. We go to our Output Conditions tab here and select the device. Node 2 in this case is the demo node that we're using right here. These are all the different outputs we have. I just have them labeled as different relays. So for example, for the fan, we can just view the settings of that. You can see here, or it's going to turn on the humidity doesn't matter. The range is set from 0 to 100%. Temperature has got to be between 50 and 78 degrees Fahrenheit for it to turn on. Fan doesn't depend on the light intensity at all, so we just make the range basically from 0 to infinity.
Hi, I am Patrick Kineski. I did a lot of work on building a backup power system. Okay, so this inverter works off of the logic constructed here on an FPGA converter circuit. It amplifies to an IGBT inverter. There's another side on the other side of the heat sinks here. The technique I used was voltage cancellation PWM, which is derived from a phase shift between the two bridges. The filter that I have sort of developed starts with rectification and then goes through an LC filter. Right now we're stepping up about 1 volt, 1.2 volts up to 15 volts. We're just doing it at low voltage for demonstration purposes. For debugging purposes, we put together an on-the-spot sensor that can show you particular values. For instance, if you needed to know what range your temperature was already in when you wanted to program for the website, you might want to know exactly where it's at right now. So real-time data is what this is good for. We also provided a spectrometer. Crap.
Nice work.
There we go. Hello, my name is Aaron Warren, and what I have basically focused on was developing the solar tracker system. And these are 2 solar panels, both 18 volts apiece. And this solar tracker design basically is ran off of Arduino Uno, and it has 2 micro servo motors, and basically one for the horizontal axis and the other one for the vertical axis. And then we have 4 LDRs which react to the light sensitivity. And basically what we wanted to do was connect both of the panels in series to create a 36 volt supply to the batteries. These are all 12 volts apiece, to basically feed into the inverter right there. And so just a demonstration to show kind of how it works. So basically it moves according to the light. that's a good demonstration of how it works.